The topic for this video is the periodic table. These are some elements that you will want to start memorizing the names and the symbols so that you can, it's just going to make everything so much faster for you. You don't need to copy these down right now. You can refer back to this, but I just would highly recommend you start maybe making yourself some flashcards. These are some more. Again, I would definitely have you know the first 20 in the periodic table. It's just going to make your life a lot easier. Okay, so the essential questions for this video are: what contributions did Mendeleev and Moseley make to creating the periodic table? How is the periodic table arranged? And can you predict properties from an element's location in the periodic table? So, Mendeleev's periodic table. In 1869, he created a periodic table in which he listed the 63 known elements in order of increasing atomic mass. So you'll notice right now they're actually not necessarily in increasing atomic mass, although they're pretty close. This is what this looked like. He was a Russian guy, so obviously this is written in Russian. He grouped the elements with similar chemical properties together, and he left blank spaces or gaps where there were no known elements with the appropriate properties and masses. Basically, he was saying, we're going to discover more stuff, guys, and we're going to leave blanks because there's something that goes there. And that's pretty genius. Henry Moseley came along in 1913, and he used X-ray diffraction to determine the number of protons in the nucleus of an atom. And the periodic table was then arranged in order of increasing atomic numbers. So they switched from atomic masses to atomic numbers, which, as we know, is the same as the number of protons. Okay, so Dmitri Mendeleev created the first accepted periodic table in the 1800s. He has element 101 named after him, Mendelevium. Now, though, we go by increasing atomic number thanks to Moseley, and we also know that they're arranged by groups or families, and those are the columns, which is up and down vertical. Okay, the elements in a column have very similar properties. They're going to interact with different elements in a similar way. They're also arranged by periods, which is the rows across horizontally. So if we need to identify the element in group 2A, period 4, that's calcium. 7A, period 5 would be iodine. And this is going to be easier if you have your periodic table out in front of you. And then group 1B, which is the short little columns in period 4, that would be copper. Okay, so the metals, nonmetals, and the metalloids, I know this is kind of hard to read, but over here you can see the colors, are the metals to the left of the zigzag line, except for hydrogen. The nonmetals are to the right of the zigzag line, and hydrogen, and the metalloids are on the zigzag line. So the properties of metals. They have a high melting point, except for mercury, which is a liquid. They are shiny. They're good conductors of heat and electricity, which means they allow those things to pass through. They're malleable and ductile. Malleable means you can hammer it into a sheet, like a thin sheet, and ductile means you can draw it into a wire. There's something that's malleable and ductile. And they're easily oxidized, which means they lose their electrons when they react. Okay, and there's an example of rusting, which is a chemical reaction that a metal goes through. They also form basic alkaline oxides. Properties of nonmetals: they have low melting points. So for the most part, they can be anything, solid, liquid, or gas, where metals are almost all solids at room temperature. They are poor conductors, which means they don't allow energy to travel through them. Their solids are brittle and dull, if they are a solid, like sulfur. They tend to gain electrons in chemical reactions, which means they are reduced. And they form acidic oxides. Okay, the properties of metalloids, which are on either side of the zigzag lines. So some examples of that are boron, silicon, germanium, arsenic, and antimony. Aluminum is not. Aluminum is a metal. Properties are intermediate between the metals and the nonmetals. They share a little bit of both. Sometimes they're halfway in between. They are used as semiconductors industry. Silicon is used in computer chips. So we said metals are conductors, nonmetals are not. These are semiconductors.